Okay, guys, today we're going to actually start a new topic. We're going to talk about center of mass and momentum later on. Mainly today we're going to concentrate on studying system of particles. So far we're dealing with only one particle, about an object that slides down a slope, or an object that moves on a horizontal plate, or an object that rotates. But we never studied more than one object. Maybe studied two objects together, but we did not study system of particles. Today we're going to study a system of particles, and when we talk about system of particles, it's very important to find out where is the mass of that system. So if I talk about us as class, if I talk about Ali, then if I ask you guys what is the mass of Ali and where is that mass is concentrated at, we can answer that. That's easy. The mass of Ali is 10 kilograms, and it's concentrated maybe in somewhere in his belly. And this is mainly because it has a uniform distribution of masses. But if I talk about all of us as particles, and if I ask you guys where is the mass of that system, all of us, then we have to find out how to calculate that. And we have some people who have some background on that, and they said we have to find out where is the center of mass. The center of mass, this is an important topic when we talk about a non-uniform object, or even a uniform object, and system of particles. We're going to talk today about the center of mass, how to calculate it, the velocity and the acceleration of the center of mass, the dynamics of the center of mass, and when I say the dynamics of the center of mass, I mean Newton's laws for that distribution of masses, that system, and the kinematic equations. Then later on, not today, but maybe tomorrow, we have a class tomorrow, we're going to talk about linear momentum and conservation of momentum as well. So Newton's second law, what did we study so far? What did we cover in this course so far? We talked about Newton's laws, Newton's second and third laws, especially Newton's second law as a starting point, and we said that sum of the forces equal to the mass equal times the acceleration. So if you add up all the forces on a specific object, that should equal to the mass of the object times the acceleration the object moves with. We talked about forces, and we actually have divided those forces into non-contact forces like gravity, right? And contact forces like friction. You need contact to have friction. So we talked about forces, gravity, spring, and friction. We talked about tension in wires, and we talked about how to draw the free body diagram and the importance of how to draw the free body diagram. We also have studied work, how to calculate the work if you have a uniform force, or a constant force or non-constant force. We have also said that the network done by all forces, that should equal to the change in the kinetic energy, and this is what, to remind you, this is what we called it the kinetic energy work theory. All the work done will equal to the kinetic energy of the object. And later on, we talked about potential energy and conservative forces. And we said, if you have a force, and if the work done by that force does not depend on the path, then we call that force a conservative force. But if it depends on the path, then this force is non-conservative force. So can you give me an example for a conservative force? Gravitational force, that's a conservative force, because if I move an object from that point to that point along that path, or I move it that way, the work done to move it from point 1 to point 2 along that path now, number 1, or path number 2, that does not depend on the path. It's the same. It's going to be m times g times h. And we know how to calculate the force. Sorry, the work done. So can you give me an example for non-conservative force? Frictional force. This is obviously if you move an object from point 1 to point 2. So I'm going to draw point 1 and point 2. 1, 2. And if I move an object, any object, from point 1 to point 2, the work done during that path is going to be different than that path. The work done by the friction force. The work done will depend on the distance in that case. And we talked also about the change in the potential energy will equal to negative the work done. And we talked about the total mechanical energy, the total energy, which says the total mechanical energy is the sum of the kinetic energy and the potential energy. This is the meaning of the total kinetic energy. And the total mechanical energy is conserved if there is no dissipation or external forces. If there is no dissipation, if there is no losses in the energy, then the total forces will be conservative in that way, and it's going to change. The total mechanical energy will change from a point to another if you lose energy. This is like the example number 4 in the assignment. In the assignment in homework number 4, we had an object that moves up a slope and moves down the slope, and I ask you guys to find the velocity after it moves down again. I gave you the velocity, initial velocity at the bottom, then I told you it's going to move up to a distance x, then it's going to move down again, and I asked you to find the velocity at the end of the slope again. And the answer is going to be, it will have the same velocity if there is no friction. It goes up, it will transform all that kinetic energy into potential energy, and if it moves down, then that potential energy is going to be transformed again into kinetic energy, and the velocity is going to be the same if there is no friction. But if we have friction, then we have to account for the friction or the energy loss due to the frictional force when we go up and when we go down. So in that case, we have to put that into consideration when we apply the conservation of energy law. Now, system of particles. This is the topic of today's lecture. If we assume that we have a disk, that disk is actually composed of many particles in it. I will concentrate only on those 2 points, only two particles on that disk. Now guys, will they have the same angular velocity? No. Will they have the same angular velocity? Ali said no. Ali is an A student. Yes. And Hassan, right? Hassan, he said, actually yes, they will have the same angular velocity. And Hassan is also an A student. Which one should we believe them? Should we always believe an A student? Should we always believe an A student?
It depends on how the particles are related with the disk.
Well, they are at the same disk, and the disk is rotating. So now, you know my famous demonstration that I use all the time in my class? Two particles, and they will rotate. Do they move with the same angular velocity? Yes. Do you all agree? Isra? Do they move with the same angular velocity? Yes. Those two objects, those 2 points, 2 particles, they will rotate with the same angular velocity.
But doesn't the angular velocity depend on the radius?
Does the angular velocity depend on the radius? Yeah. Hassan is saying no. Actually, the linear velocity is related to the angular velocity by the radius. So, though they will have the same angular velocity, but that equation will tell us that they will not have the same linear velocity. One of them will have, the one that has longer radius will have more linear velocity than the one that has a shorter radius. So this is what we're going to study today. We're going to divide an object into many particles, and we will study the motion of those particles. And before we do this, we have to find out where is the mass of those particles. So I brought to you today something that we all have observed during our life. those are two objects. One is heavier than the other one, and I want to hang that from some point in here in such a way that it will stay horizontal. And that point will give it a definition later on. Where should I put my finger? Here, here, or here? In the middle, or a little bit to my left, or to a little bit to my right?
To the heavy object.
Ali is saying to the heavy object, and the heavy object, that's Nada, right? Minna? So here guys, where should I put it?
Near the heavy. Yes.
And that point, we're going to give it a name later on, but more important than giving it a name, what does that point mean?
Center of mass.
That's the name.
It means that the revolve around this point is
I'm sorry, I don't know what does that mean. Torque, we did not study anything that says torque yet. So I have no idea what is torque. Actually, what did you say?
equilibrium.
Well, this point will entail having equilibrium for that system. The system is at equilibrium. Where is the mass of that system?
Right under it.
Where is the mass? If you look at that system as one point, if you look at that system from very, very far away, it will look as only one point, one single point. And the mass of that system will be concentrated at that point. Where is that point located? Here, here, or here? And that's under my finger. So if I look at that system from far away, it will look as one point, and that point will have a mass, the mass of that whole system, and it's going to be under my finger, somewhere in here. And that point, we're going to call it center of mass. That's where all the mass of that system is concentrated at that point. The mass of that system is concentrated at that point. Obviously, if I change the masses, that point will change. So I change the masses. Now I'm going to look for a newer center of mass. Okay, guys, and this is the new center of mass. You know, if you consider this system as only one single point, okay, what will be the position of that point? Position of that point, it's going to be under my finger. And that's where all the mass is concentrated. This point is called the center of mass. Now, guys, can you come up with a way to calculate the position of the center of mass? Now, what I did is, now I changed the masses. Now, this mass is a little bit heavier than that. So I moved my finger from that location, when I used that mass, to the new location here. My finger does not have a brain. It cannot actually think. But you guys can. How can we calculate mathematically the location of the center of mass?
Multiplied by the length. It should be the weight times the distance.
I forgot your name. She now is saying, well, the weight times the distance. What does weight mean? So he's saying the force times the distance should equal the force times the distance.
Mass force. Not weight. Force is not force.
But this, if I do this, so I'm going to say, this is what you're saying. Okay, Shinawi, you're saying M1G times X1 equal to M2G times X2. Correct? Correct? Or times the total length minus X1. That's what you're saying, right? So I will keep it as X2 for now. Now we have two unknowns, one equation. We have two unknowns, X1 and X2, and one equation.
خليها left minus x. احنا اكيد
Yeah, if you have the length of the rod, then I think you can get x1 now. This is one way to calculate the center of mass. That's correct. But this actually entails something that Hassan talked to us about a minute ago, that's torque, and I don't want to go there yet. Can you come with another technique, another way to calculate the location of that point? Ideas? So, what to do? Before, when we went and studied the motion of an object, there was something that's very important to us to actually to do before we get into calculation, and that was defining our coordinate system. Do you remember that? So if I want to locate Shinaw's position, then I have to say this is the coordinate system of that universe. This is X, this is Y, this is Z, and from that position I can measure Shinaw's position or Vanessa's position. Can we do the same here, since we're looking at position of a point? Can we do the same? Can we find an origin for that system? That can be one end of that object, here or here. That can be the origin, or it can be that point, right? So this is the origin, for example. Those are the two masses. This is the origin. Now I want to calculate the center of mass. So how can we calculate the center of mass? Remember, when I say the center of mass, this is the position of that point. It's a position of that point relative to the origin. Yeah, but we don't know where is the center of mass for that point. So can I do this? The center of mass equal to guys. What did you say? M1 plus M2 divided by 2. Is this equation correct? Do you think this is the correct equation? Why not? This is the average of the two masses. And to make sure that this is really the average of two masses, what is the unit of the left-hand side? Meters or centimeters. It's a length unit. What is the units for the right-hand side? Kilograms. That cannot be correct. Total mass over total distance. So sum of the masses divided by sum of the distances. Right? Look at the units again. This is correct. No. What else?
If you're going to deal with the masses, you're not using the kilograms, then you have to divide the mass with the mass.
So Sharif is saying you have actually to divide by the total mass, sum of all the masses. Mass over mass, that's going to be a ratio. It's unitless.
Yes, but then if you
multiply by the total length.
Multiply by the total length. How about this? I'm going to modify what you said a little bit. What does that mean? It means sum of mi xi, that means that x1 m1 plus x2 m2 divided by the sum of all masses, m1 plus m2. It means that you find the position of the first mass, that's 3 meters away, 2 meters away from the origin, that one. So it's going to be 2 meters times the mass of that one. It's 100 grams, so it's 0.1 kilogram, plus the position of the second one, that's 2.2 meters, it's almost 20 centimeters. So the position of the second object, that's 2.2 meters, times its mass. Its mass is going to be 0.2 kilogram divided by the total masses, which is 0.1 plus 0.2. And this will give us the location of the center of mass. Okay? So now, again, so what I said is, what Sharif suggested a minute ago is to do this. To find the mass of the first object times its location, its position, plus the mass of the second object times its position divided by the total masses. So if I do this, this will give me the center of mass. The units, from the units point of view, the left-hand side has the units of length. The right-hand side has also the units of length, and this will clearly give me the center of mass. Again, center of mass is the location of the point that all the mass of the system is concentrated at. And if I take that definition into our classroom, we all are particles in this classroom. We are a system. The system, Yasmin, is composed of all of us. And I want to calculate the center of mass for that classroom. So what to do? What to do? Before I do it for the whole classroom, I'm going to start by only that row. I will calculate the center of mass for only that row. Then I will carry that into calculating the center of mass for the whole classroom later on. For that row, how to calculate the center of mass for those 5 people? Define a coordinate system. That's my origin. This is my x-axis, and this is my y-axis. Correct? Then define the position of each one of them. x1, x2, x3, 4, and 5. Then its position, so it's going to be m1 times x1 plus m2 times x2 plus, and so on, divided by the total masses of all those 5 students. If I distribute the masses into 2 dimensions, x and y, that's all of us in class, how to calculate the center of mass? Say that again. Sharif is saying you take the component of the x and the component of the y. What Sharif is saying is the center of mass now, it's a point in space, and it will have 2 coordinates. It will have an x coordinate and it will have a y coordinate. So I have to calculate the x center of mass and the y center of mass. What Sharif is saying is the following. For our classroom, you have to calculate the x position of the center of mass and the y position of the center of mass. And the y position, can anyone tell me how to, what will be the equation? It's going to be summation of mi yi divided by sum of all masses. Okay, for our classroom, I need to find out where is the center of mass for this group of students. What to do? Choose the coordinate system. So this is my origin again. I'm going to move in here because we have, this is x, sorry, this is y, this is x. Doesn't matter which is y and which is x, and we have agreed on that before. So this is x and this is y. Now, guys, we need to calculate the center of mass. What to do? I want to see hands. No, I want to see hands. Anyone else? Sharif, not Hassan. Vanessa, thank you for raising your hand. So, I need to calculate the center of mass. What to do?
We take the mass of
Ali? Yeah?
times the distance.
Times which distance? X distance, X position, or Y position? X position and
And then the second one,
then M2x2 plus, then M2x2, then M3x3 plus M4x4, and so on for the whole class, divided by the sum of the masses for the whole class. Then we'll get the x position for the center of mass. So Vanessa told us it's going to be x1 m1 plus x2 m2 plus x30 m30 divided by m1 plus m2 plus m3 and so on, m30. Now we were able to find the location, the x location of the center of mass, the x position of the center of mass. Y position, what to do? May? Minna. Minna?
The mass of the object and then components on the y-axis plus the mass of the other object and components on the y-axis.
Okay.
And then divide them by the total of the
Can you tell me what will be the position of Ali on the y-axis?
0.
0. Can you tell me what will be your position on the y-axis?
3 times my
No, your position, only your position on the y-axis. What is your y position? How to measure that? This is the origin. So this is 0 and 0. So can you give me an estimate for your y location, your y position? Just an estimate. How many meters will it be? 5. Those 5? Or those 5? This is but this is x position. Okay, this is x position, and this is y. So your location along the y, it's 5 meters. It's actually close to 3 meters, not 5, but that's fine. So your position is gonna be at 3 and 7, almost 7. That's your position, guys. In your head, look at the origin, and I wanna each one of you tell me what will be his position. And I'm going to ask any one of you.
the x-axis or
Your position in space. As a point. In space. Okay, are you ready? Should I start asking people? Ahmed, right there. Say that again. No, I want to find out what is your position. What is your coordinate? How can I describe your location? You're located at, from my position, how many meters? 10, 12, along which axis? X-axis. And how about the y-axis? What is your position along the y-axis? 0. Yeah. So you're at 12 and 0. That's your location. Vanessa, how about your position? 10, 12, yes. 10 and 5. Yasmin. So what's your position according to the origin?
the origin.
Yeah, that's the origin.
For x is e.
For x, this is x, by the way. That's x, that's y. Yeah, just an estimate. I don't want an accurate measurements. I just want an estimate. 1, 2, 3 meters, right? That's 3 meters. And y position is 1, 2, 3. Almost 3. Okay? Assuming that one step is 1 meter. So this is how we measure the position of each one of us. So guys, this will give us a way to calculate the center of mass for that group, for all of us. It's mainly along the x-axis, Ali's mass times his position along x, plus forgot your name, Taha's mass times his position. And if I keep doing this for the whole class, I will find the x center of mass. And if I do the same for along the y-axis, I will find the y center of mass. And at the end, you get the center of mass of all of us given as 2 points in space. It's 10 and 7, for example. 10 meters from the origin and 7 meters, 10 meters along the x and 7 meters along the y. And this is the coordinate of the center of mass. Yeah, this is going to be x along the I and 7 along the j. And this is the way we write the coordinate of any point according to the Cartesian coordinate system. I, we write the I first, the x first, and j. Yes? Farida? Yeah, okay. So, back to the slide, yes.
So, Ali and the Y.
Yeah, they are 0. If I go back to the origin, now, what's the y position, y location of Ali? 0. And Taha? 0.
So, is it they're not there again?
Along the y-axis? Yes. They have no effect. They do have an effect because actually if you look at the masses, at the end, it's the mass of Ali times his position along the y. That's going to give you 0. But you're going to actually, his mass is going to be shown when you add all the masses. Okay? Okay, guys? So, if you have an example of 4 points, that's M1, M2, and M3, and M4, and if we need to find the center of mass of those only 4 points in space, that's going to be easy. The center of mass is the mass of sum of the masses times their position divided by the sum of all masses. And if you look at that equation entails the x position for the center of mass, the y position of the center of mass, and the z position of the center of mass as well. R is a vector in space that has x, y, and z component. So, if I have only 2 masses, if we want to calculate the center of mass for those 2 locations, then I have to find out where is the origin, and I can choose the origin wherever I want. So this is going to be the origin, that point. So the center of mass for those 2 points is going to be M1 times R1 plus M2 times R2 divided by M1 plus M2, and this should give us the center of mass for those 2 points. If we carry that to the demonstration that we have shown today, in order to balance that system, that's when you said equilibrium, that's when we balance that system. This is where the center of mass is located. And the center of mass for that system is going to be M1 times x1 plus m2 times x2 divided by m1 plus m2. Guys, in this equation, in that system, where should I choose my origin? Here, where? Hassan is saying, well, I'll choose along that line. So Hassan is saying you can choose here, there, or there. Any point along that line. Oh, Nada, right? I like that question in here. What did you say again?
Does it make a difference because you said, for instance,
Yeah, this is the most important part we should ask ourselves first. Does it make a difference to choose my origin system? Will it give me a different answer if I choose different coordinate systems? Well, no, the answer is yes. Ali said that. Ali said, well, actually, no, it's not going to make any difference in the answer. The answer is going to be the same no matter where you choose the origin. But it might be shorter answer if you carefully choose your origin. So if I choose the origin in here, this takes us back to your question when you said this is as if the mass is not there. If you choose it here, then how to calculate the center of mass? Simply, the center of mass in that case is going to be m1 times 0 plus M2 times the length of that rod. If you choose the center, the origin at that point, then it's going to be M1 times its location, which is 0, plus M2 times the length of that rod, divide that by M1 plus M2. And this should give us the center of mass. Of course, this will be a little bit easy if I choose that 0. Yes? 5 minutes. Yeah. I thought you were asking.
Why is that not 0?
Yes.
At the very end.
Yeah, because this is M1, that's M2, and I choose this to be my origin. So M1 is located at 0 point from the origin, while M2 is located at L meter from the origin. Okay? Okay, yes. Minna. Yeah, I got that right this time. Yeah.
The object has an X and a Y component that are known with are different. None of them is 0. How can we calculate it?
So many things. This is that's your system. That's M1 and that's M2, and you choose this point to be your origin, right? In that way, then I have to find out what is the location of that point. That location is going to be at X equal to 4, 1, 2, 3, 4, 5, 6 units. Okay, and Y point is going to be 1, 2, 3, 4, 5, 6 points, 7 points. And so that point here is located at 6 and 7. Its X point, its coordinate is 6 units from the origin, while its Y coordinate is at 7 points from the origin. And this is going to be, let's say, 10 and 40 and 7. Now, how to calculate the center of mass in that case? So, X center of mass. Can you see that, guys? X center of mass equal to M1 times plus M2 times 10 divided by M1 plus M2. The Y center of mass. Minna. Yes. Yes.
By choosing one of the points to be the origin system, it makes it more easier not to locate every point.
Yeah. How about the Y center of mass? Minna, you have to give me an answer. The Y center of mass. 7. It's M1 times 7 plus M2 times 7 divided by M1 plus M2. And if you look at that equation and you examine it carefully, it makes sense. It will make sense that the Y center of mass is going to be 7. Because they are along the same line. The X center of mass is going to be somewhere in here between them. But the Y, no matter what are the masses, it's going to be always 7. Because they both are along the same line.
But different of the origin point will not get us a different answer?
No. Of course, the answer is going to be the same, somewhere here between them. Some here between them, relative to one of them. But relative to the origin, it's going to be different answer. But the position relative to any one of them is going to be the same. Okay, guys? Okay, give me 1 minute. 2 more minutes. Hani, no, you have to wait with me. Guys, before we move, before I leave the classroom, I want you to, for that example, to give me the center of mass. For that example in here, to give me the center of mass. And I have 3 masses, M, and 2M. Number 1 is located at 0 and 0. Number 2 is located at 24 and 0. Number 3 is located at 12 and 12. We need to calculate the center of mass for that system. Hassan, what did you say? So we have an answer. I'm not sure if it's correct or not. Just means we have an answer. Can you get an answer, please? Azam, do you have an answer?
Well, we know what
That's what Hassan did. He got the X and he got the Y, but he gave me the final answer. So yes, the answer is yes.
we don't know the actual numerical value of the mass.
No, no. You have M, M, and 2M. The masses are M, M, and 2M. You have an answer? Is it the same? I have another answer. You have 3 answers. You have the same? Are you sure? Ali is the same. Vanessa? What's your name? Abdurrahim. Do you have an answer? So most of the people are getting the same answer. Abdurrahim, you're going to do it. So you have to give me an answer. Ahmed, you're going to do it. Are you ready to give me an answer? Azam? 12 and 6. Taha? Abdurrahim, what to do? How can I calculate the center of mass? So I will say that X center of mass equal to summation of mi xi divided by sum of all masses, and that means that mass number 1, guys, mass number 1 times its position as 0 plus m2, which is m, times 24 plus 2m times 12 divided by 3m, 4m. And the 4m came from m plus 2m's, 4m. This is the X center of mass. The Y center of mass, Abdurrahim, is going to give it by m1 times 0 plus m2, which is the other one along the x-axis, times 0, but that's why, because it's along the x-axis, plus 2m times 12 divided by 4m. Then you can actually get a numerical value for this. And you can see that even though the m is not specified, but we got a numerical value for the center of mass regardless of the value of the m. The only thing that we know that this one is given as a function of m. So guys, I'm going to stop here and